Welcome to the Explainer. Okay, let's just dive right in. Because today, we're looking at something that honestly feels like a literal magic trick. We're talking about a brand new 58-page research paper that details a practically free, open-weights AI model that is suddenly going toe-to-toe with the absolute giants of the tech industry. I mean, we're talking about DeepSeek V4. This is a system pulling off technical feats that, honestly, just a few months ago seemed completely impossible for anyone outside of a multi-billion-dollar corporate fortress. It's just an incredible time to be alive, and I absolutely cannot wait to show you how this all works.
Now, if you're kind of new to the AI space, you've probably heard of these massive, incredibly expensive frontier systems, right? The ones built by huge tech conglomerates with, seemingly bottomless budgets. But look at the underdog here. DeepSeek V4 is shaking up the entire landscape because it's open and it's free. And yet, its Pro model produces results that basically match those billion-dollar frontier models from just a few months back. And it's essentially just been gifted to us mortals to use. It fundamentally changes the game of who actually gets to play with top-tier artificial intelligence.
So, the big question is, how on earth does it actually do this? Well, we have to start with its memory. In AI terms, we call the short-term memory the context window. Like, just 2 years ago, the whole tech world flipped out when Google's Gemini introduced this massive context window. But DeepSeek? It's offering a 1 million token context window in an open weights model. To put that into perspective, you can literally ask this AI to inhale about 1,500 pages of dense documentation all at once, and it'll just do it. For free. It sounds absolutely absurd, but they actually pulled it off.
Section 1. The magic of compression.
So how does inhaling 1,500 pages actually happen without completely crashing the system? It all comes down to the KV cache, which is basically the AI's scratch pad. Think of processing all this information like reading a massive book. DeepSeek essentially does 3 genius things to speed this up. First, token-level summaries. Imagine compressing every single paragraph of a book down into just one sentence. You've still got the whole story, but you can search it way faster. Second, it looks at the structure. They call this heavily compressed attention, which is a crazy 128-to-1 compression. It's kind of like looking at a table of contents. You grasp the whole plot at a glance. But that's still not enough. So third, it uses an index, or compressed sparse attention. Say you're looking for a specific fight scene. This index immediately hands you the top 5 pages where the fights actually happen. Summaries, structure, index.
When you click those 3 pieces together, DeepSeek drops the memory needs for its scratch pad by about 90%, literally squashing 100 words into a storage space of just 10. And the wildest part? They're doing this without losing basically any crucial information. The model can still successfully recall facts hidden deep inside that heavily compressed memory. It even beats out some major flagship products on certain tests.
Okay, but I do need to give a quick reality check here. While that 90% compression for the scratch pad memory is totally amazing, you still have to load the massive full model itself to actually make it run. So despite what the online hype might lead you to believe, no, you cannot load the full DeepSeek Pro AI onto your cute little smart toaster. You still need some pretty serious hardware to host this thing yourself.
Section 2. The forest walk.
So, now that we've compressed the memory, how does the AI actually process it all so fast? Well, imagine you're walking through this beautiful forest. You really want to look at the amazing views, right? But if you only look up, you're going to trip over a root. And if you only look down at your feet, well, you completely miss the view. You can't just do one or the other. You really have to do both. Scan near and glance far. Step and look. Local detail to watch your step. Global context to enjoy the view. That is exactly how DeepSeek balances its processing, paying super close attention to the immediate, local details of your text, while simultaneously keeping an eye on the broad, global context of the whole conversation.
And to make that forest walk even smoother, they use a really clever trick called an n-gram. You see, normally, an AI is actually pretty inefficient. It recalculates almost every single fact from scratch every single time. But the n-gram acts like a dedicated recall mechanism. It lets the AI just remember those past facts instead of doing all the complex math over again. It saves a massive amount of time and energy.
Section 3. Blind, deaf, and hallucinating.
Okay, while the hype is very real, we definitely need to temper our expectations and look at where DeepSeek V4 falls short. Remember that 1 million token context window? The 1,500 pages? Well, just like a lot of other systems out there, if you start pushing right up against the absolute limits of that window, the AI starts to break down. It'll begin to forget things, it'll drift totally off topic, it will completely hallucinate facts that just aren't there. The golden rule to remember here is more text often means less truth. You've got to be really careful when you stretch its memory to the max.
Also, keep in mind, this system is strictly unimodal. It's not a multimodal model like some of the other flashy ones you might have seen. That means no images, no audio, no video generation. It is basically completely blind and deaf. It only understands pure text. And here's a totally fascinating admission from the researchers. They don't even fully understand the system themselves. Yeah, they use two specific techniques that magically stabilize the training process, and they openly admit they aren't entirely sure why they work. It's a wonderful bit of scientific transparency for sure, but a really good reminder that this AI stuff, it's still highly experimental.
We also see its limits in its specific skill sets. Now, it is fantastic at coding. It's incredibly easy to just ask it to generate some JavaScript, paste it into a website, and boom, it runs. Some stuff you can even run directly in the DeepSeek window with one click. But when they tested it on highly advanced algorithms, like really complex ray tracing for light transport research, it completely failed to implement them properly. So it's absolutely brilliant for a lot of everyday coding, but it definitely still has some hard boundaries when it comes to highly specialized tasks.
Section 4. Intelligence too cheap to meter. Balancing the brilliant compression against those limitations leaves us with what is easily the most disruptive part of this whole paper, the sheer economics. Because behind the scenes, the real magic trick is efficiency. As the new Pro model runs, it requires about 3 times less computing power than their previous version. And they even released a lighter Flash model that's surprisingly competitive with the Pro, but takes roughly 10 times less computing power. The leaps in efficiency here are just staggering.
And because it needs so much less compute power, the cost just plummets. If you use their online API access, the pricing is literally so low that the numbers kind of start losing their meaning. Depending on discounts, major commercial frontier models, like Anthropic's Claude for instance, can be 8 to 30 times more expensive than DeepSeek V4. We're talking an entire order of magnitude cheaper than the competition.
Which really brings us to our final takeaway. We've seen how DeepSeek V4 uses these unbelievable compression techniques to handle massive memory. We've seen how it balances local details and global context. You know, that walk in the forest. And yeah, we know it's blind, it's deaf, and it can definitely hallucinate if you push it too far. But at the end of the day, it is offering top-tier reasoning for a fraction of the compute power, and at an absolute fraction of the cost. So, I'm going to leave you with this. What actually happens to the world when massive, highly capable intelligence becomes virtually free for everyone? Think about that. Thanks for exploring this with me today, and keep questioning what's possible.